Welcome, my dear students, to this fourth lesson of NAT64 DNS64 implementation lessons. You remember in the last lesson we complete the configuration of NAT64, DHCP and R2 routers, and now the network has a connectivity and the DNS V6 is working properly. So if I need from R2 to ping, for example, the DHCP6, okay, I can see here that the success rate is 100%. That means there is a connectivity between R2 and DHCP and the DNS server is working properly. And here I can see that the translating of DHCP has been done in the domain server in this IPv6 address, which is the IPv6 address of the server. Then it sent 5 ICMP echo messages and it gets 5 replies. That's why the success rate is 100%. So the domain server is working properly now. Okay, now in this video we will complete the configuration of the right hand side of the network, which is IPv4 network. You remember we did assign an IPv4 address to this interface in the previous video. The interface of GI2 in NAT64 router. So we will complete the configuration of this router and we will apply this router as a DHCPv4 router, so it will distribute the IPv4 addresses to these two PCs. These two PCs are normal virtual PCs installed within the GNS3 software package. So we will start. I will start this router. Okay, then open the console. Okay, very good. Now we will start the configuration. So configure terminal. The interface of F00 will take the IPv4 address, which is 172.20.0.1, and the subnet mask is 255.255.0.0, and no shutdown. I need to enable the OSPF on this interface. Area 0. Okay, now for the second interface, which is F01, this interface, it will get the IPv4 address, which is 172.30.0.1 and 255.255.0.0. Not shut, and to enable the OSPF routing protocol. Now for the loopback interface, okay, the IPv4 address is 172.2.2.2 and this is the subnet mask 255.255.0.0. Enable, sorry, we need to put 0 here. Okay, enable the OSPF, then exit. Then I need to again to add a default root, IP root, but this time it will be yes, IPv4 protocol 172.20.0.2. So this is the default root. Okay, that means if any traffic, any packets that this router does not know where to send, it will, the router will send it to this interface. Okay, and just to be sure, show IP interface brief. I can see here that this is Ethernet 00, fast Ethernet 00 is 20.0.1 and fast Ethernet 01 is 30.0.2, and this is the loopback interface. Okay, now the next step is to configure the DHCPv4 on this router, so these two PCs will get IPv4 addresses automatically. Configure terminal. Okay, I will exclude from the DHCP some addresses which is from 30.0.1 up to 30.0.10. This will be excluded from the pool. Excluded, yes, from the pool. Then define the pool name IB DHCP pool. The pool is IPv4 pool name. Pool, yes. Now for the network is 172.30.0.0, and this is the subnet mask. Okay, the default router is this router actually, which is 172.30.0.1, and I don't have DNS server, so I will end the configuration. Okay, that's all for the router. Now let us check the PC, starting with PC1, to verify whether this PC has assigned IPv4 address from the router. Start, then open the configuration. It will take time because I'm opening this server and this router. How many router? 1, 2, 3, 4. Yes, 4 router with server, so it will take some time, depends on the RAM available. Okay, for this type of virtual PC. To set up the DHCP, you need to write DHCP only. Okay. Okay, this is the IPv4 address that is assigned automatically through the DHCPv4. Okay, that's all for this short video. We only configure the right side segment, which is IPv4 segment. Now we have two segments, IPv6 only, native IPv6, and IPv4 only or native IPv4. We need in next video to implement the NAT64, so this segment will communicate with this segment through this router. Thank you for watching. See you in the next video.